All right, so here we go. Let's go ahead and work through the odds on 3.2. We're doing the second page, numbers 11 through 19 odd. So starting off with number 11, continuing our progress that we made from the previous problems, we are just factoring the quadratics and then canceling out common factors in the numerator and denominator. So we're going to continue doing that. So first off, since this is multiplying, this all just becomes one big old fraction. And we just need to start canceling stuff off when we can. This one's actually pretty cool because look at this. We have an 8r squared plus 80r in the top and the bottom. So we don't need to even factor that. The whole thing is just going to cancel out in the top and the bottom since it's in the numerator and denominator. So we just need to factor these two and that's it. So let's see here. I need to find out numbers that multiply together to be 50 and then add together to be 15. So those two numbers are 5 and 10. So this top part factors to be r plus 5 times r plus 10. And then in the denominator, let's see here. So numbers that multiply together to be negative 30, and then add together to be 7. So let's see here. That's going to be 10 and negative 3. So in the bottom, we get r plus 10, and then r minus 3. And then the r plus 10s will cancel out because, you have one in the numerator, one in the denominator. So we're left with r plus 5 in the top, and r minus 3 in the bottom. That's our simplified expression, and we are all done with number 11. All right, now we're going to work on number 13. So number 13, 15, 17, and 19 are different in that we're dividing by a fraction. So you're going to have to remember this one little rule with division of fractions, and it goes something like this, okay? If I have a fraction, like 3/4, and I want to divide it by another fraction, like let's say that we're dividing by 5 over 7. So the way that I do this by hand is, it's this little rule that you guys might have learned in algebra or maybe even before that of keep, change, flip, or something like that, where you keep the first fraction the same, you switch the sign from division to multiplication, so it's 3 over 4, and then from division to multiplication, so times. And then what you do is you take the reciprocal of this one. So reciprocal means that you flip the numerator and the denominator around. So these two flip, so you get 7 over 5. We're going to apply this rule of dividing fractions to rational functions with division. So it's a really quick way to change from dividing to multiplying, and that should be really nice because we've just been multiplying fractions together. So it's going to be, more of the same stuff after we do that. So let's just do that one quick little thing and see how that affects everything. Okay, so we're going to change division to multiplication. So we keep the same one, keep the first one, so it stays the same, 3 over v plus 8. Then we change the division symbol to a multiplication symbol, and then we flip this fraction around. So it's going to be 30v, and then in the top it's now going to be v minus 1. So the whole bottom part goes into the top, and then the whole top part goes to the bottom. So we have 30v times 1 minus v. All right, so now we can start canceling stuff out because this is just one big old fraction that we're working with. So I notice that I have a 30v in the top and a 30v in the bottom, so both of those are going to cancel out. So I'm left with 3 times v minus 1 over, parentheses, v plus 8 times 1 minus v. So these two are really similar, this one and this one, but I need to make them look the exact same before I can cancel them out. So here's how I can do it. If I see that I have the same exact numbers in it, but they're just kind of reversed, like notice that this is v minus 1, this is 1 minus v, so they're just switched around. If it's addition or subtraction or whatever, well, actually just strictly subtraction in this case, what we would want to do is turn this one into this by just basically factoring out a negative. So let me show you how that works out. If I were to take 1 minus v and factor out a negative 1, how would it look? Well, it would be a negative 1, and then 1 divided by negative 1 is negative 1, so this becomes minus 1. And then negative v divided by negative 1 is a positive v. So there's this rule called commutativity of addition, and that means that I can switch addition around and it's the same thing. So I'm just going to switch these two numbers around and see what I get. So I get negative 1 times parentheses, and it's going to be v plus a negative 1. In other words, minus 1. So see, I've just changed this from 1 minus v to a factor of v minus 1. So I'm going to replace this part, 1 minus v, with negative 1 times v minus 1 and see what I get. So you have 3 times v minus 1 in the top, and then in the bottom I have v plus 8, and then I've got negative 1 times v minus 1. See, so I just replace that in there. So this -1 is a factor in there, so it's multiplying. So I can just, claim that this is a negative and just put it out front. So this becomes negative of that fraction. And then I have the v minus 1's cancel out, so I just have a 3 in the top, and then the bottom I just have a v plus 8 after this, because, the v minus 1's cancel out. And this is my simplified expression right here. Okay, a couple more. That one's, let's see if that one shows up again later on. It doesn't look like it's going to, so that's just kind of an anomaly. That's kind of like a weird one, but that's how you get a negative out of it. Okay, so now 15. So, do the same rule, keep the first fraction, change the sign, flip the second fraction. So keep the first fraction, 3x squared over x plus 1. Change the sign from division to multiplication, and then flip the second fraction. So that's going to be x minus 5, x plus 1 on top, 3x squared, x minus 9 on the bottom. Now let's make sure we put parentheses around this factor here. All right, so let's cancel out the stuff that's in common in the top and the bottom. So the 3x squareds cancel out, and it looks like we've got an x plus 1 that cancels out. So all we're left with is x minus 5 in the top, and then x minus 9 in the bottom. Okay, moving on, number 17. Same thing, but now we have to start factoring in this stuff. So yeah, let's just do the change first and then factor it. So keep this one, change that sign, flip this one. So we have a squared minus 6a plus 9 over 50a, yeah, 50a plus 30, and then times, and then the next fraction is going to be, let's flip this fraction. So 50a plus 30, and that's nice because I have another one in the bottom, so that'll cancel out. And then I have 10a squared minus 30a. Okay, so like I said before, these two factors are going to cancel out, 50a plus 30s. So then we're just left with a squared minus 6a plus 9 over 10a squared minus 30a. Now we try to factor these. So numbers that multiply together to be 9, add together to be -6, that's -3 and -3. So I get a minus 3 in the top, and then a minus 3 again. In the bottom, looks like I can factor out a 10 from both of these, and then also an a. So if I factor out 10a, I get, let's see, 10a divided out of that is just a regular old a. And if I divide out 10a from here, I just get -3. So one of these a minus 3's is going to cancel out, so all I'm left with in the top is a minus 3, and in the bottom it's just 10a. So this is our simplified expression, okay? I need you to know this for a fact, that the a's will not cancel out, and the reason that that's the case is because we have this subtraction going on right here. If there's any adding or subtracting in the top, you can't just cancel out any a values, okay? So watch out for that. Please don't make that mistake. It's a very common one that we will see. And it's simply because of the fact that we're subtracting the a and the 3. If it was a times 3 instead over 10a, then the a's could cancel out, yes. But since it's subtracting, or if it was adding or whatever, you can't cancel the a's out. So just leave it as is. All right, the last one that we need to work on in 3.2 is number 19. So for number 19, let's go ahead and do all the keep, change, flip things. So we have 3p minus 12 over 3p minus 30 times, and then it's going to be p minus 10 over p squared minus 9p minus 10. Okay, so let's try and factor all this stuff out as best we can. So 3p minus 12, 3 and 12 are both divisible by 3, so I'm going to factor out a 3. So I get 3 times parentheses p minus 4, and then I just have p minus 10. That's just, it already is factored, so I can leave it as is. And then 3p minus 30, those numbers are both divisible by 3, so I factor out a 3, and I get p minus 10. So the p minus 10s are going to cancel out eventually. Next, let's see what numbers multiply together to be -10 and add together to be -9. That's going to be -10 and +1. So then I get p minus 10 again, and then I also get a p plus 1. All right, let's try and divide out as much as we can here. So let's see here. A p minus 10 will cancel out on the top and the bottom. A 3 will cancel on the top and the bottom. And we'll just be left with, let's see, p minus 4 in the top. And then in the bottom, it's going to be p minus 10 times p plus 1. And you can just leave it in factored form. That's completely acceptable. And that's your finished simplified expression. So that's the entire backside of 3.2. Now let's move on to 3.3.